So hello everyone, welcome to the channel. So in this video I'm going to show you the population dynamics monitoring using a GHLS dataset in Google Earth Engine. So now let's get started. So monitoring the population dynamics is essential for understanding the urban growth, resource demand and sustainable development. The Global Human Settlement Layer, developed by Joint Research Center of European Commission, provides a high-resolution gridded population dataset that offers the critical insights into spatial and temporal populations distribution worldwide. With Earth Engine, we can efficiently analyze a large-scale population dataset over time and across geographical regions. We're going to utilize the Earth Engine to perform a temporal analysis of population change using GHLS population data. A specific study region of your choice will be selected, and we're going to extract the administrative boundary using Global Administrative Unit Layer dataset. So once you define your region of interest, next we're going to filter the population dataset based on our region of interest, that is using our administrative boundary layer. And the further analysis, the user can visualize the changes in population distribution spatially over time, and more importantly, the analysis generates a population time series chart that summarizes the population trend from multiple GHLS reports. And some function is used to calculate the total population value for each time point, and these are plotted in the high resolution line chart, and this enables researchers to observe and quantify the changes in population across decades. The population in this approach includes tracking the urban sprawl and evaluating the effectiveness of regional development programs and assessing the future infrastructure needs and supporting the environmental and health impact studies based on the population pressure. Through this integration of Earth Engine and the GHSL dataset, the user can gain a dynamic, scalable, and reproducible method for analyzing the population trend with spatial precisions. So let me get back to Earth Engine. So now to analyze the population dynamics using the GHLS dataset, first we have to define our region of interest. So to define our region of interest, first we're going to define our study area boundary polygon. So in order to do that, first we're going to define a variable called country boundary equals to Earth Engine dot feature collection FAO 2015 level 11. And to add this layer, we're going to define map dot add layer country's boundary layer with the default visualization parameter, and we're going to output as country boundary. So navigate to the layer section here. So click this option called run, and once you did that, next step we're going to turn on this particular layer called country boundary, and this is a global country boundary polygon layer, so you can able to see that. And using this particular boundary layer, we're going to select our study region of our choice. So let me explain about this particular dataset. So Global Administrative Unit Layer 2015, so first level administrative unit. The dataset availability is from 2014, and the dataset provider is FAO UN. And using this particular script, you can access this dataset here. And short description about this data is Global Administrative Unit Layer compiles and estimates the best available information on administrative unit for all countries in the world, providing a contribution to the standardization of spatial dataset representing the administrative units. So you can go through the details about this particular data. So let me get back to Earth Engine, and you can able to see these are the boundary polygons. So you can select your study region of your choice. For example, I'm going to select this particular study region of my choice. For example, I'm going to click this option called add a marker. So once you click this option called add a marker, you're going to place a marker over this particular study boundary area of your choice. For example, I have selected this particular boundary area. You can select any boundary area of your choice. So once you placed your marker here, I'm going to turn this off here, and I'm going to navigate to the top section. So we have this variable called geometry, and in that we have this option called show generated code, and I'm going to copy this latitude and longitude using Ctrl+C in my keyboard, and I'm going to paste my latitude and longitude inside this variable called point coordinates. So I'm going to paste my latitude and longitude using Ctrl+V in my keyboard, and inside this variable called point coords. So once you've copied and pasted your latitude and longitude inside this variable, the next step, we're going to convert this latitude and longitude into a point data. So to do that, we're going to define a variable target point equals to earthengine.geometry.multipoint, and we're going to mention this particular variable called point coordinates. Referring to this variable, which holds the latitude and longitude of our point data. So we have pasted this particular point data in order to select this particular boundary polygon of our choice from this global administrative unit layer. So for that we have placed this point on this particular polygon. So in the next step, again we're going to load and filter your administrative boundary layer using this particular point data, that is our this particular variable target point. And so to do that we're going to define a variable called region boundary equals to Earth Engine dot feature collection FAO 2015 level 1. And next step we're going to filter it based on our study region, that is based on the point data. So using the point data we're going to filter out this particular polygon out of the administrative boundary layer. So for that I'm going to mention dot filter bound target point. So target point refers to this particular variable, so which holds the latitude and longitude and convert it into a point data. So based on this point data we're going to filter this study area polygon out. And next step we're going to center this particular layer. We're going to mention map dot center object region boundary. And next step, to add this layer we're going to define map dot add layer region boundary, referring to this particular variable. And with the color we're going to mention as blue color for the visualization, and we're going to output the layer name as administrative region. So let us visualize it. So we're going to navigate to the layer section and I'm going to turn on this layer called administrative region. So now here you can able to visualize we have managed to filter out this particular polygon out from the global administrative unit layer. So you can clearly able to visualize it. Let me turn this off. And the next step we're going to load our global human settlement layer population dataset. Now let me explain about this particular dataset. So GHSL global population surface 1975 to 2023 2030. So the global population surface dataset is available from 1975 to 2030, and dataset provider is European Union Commission JRC. And using this particular script you can access this global population dataset layer. So we can go through the description about this particular dataset. This raster dataset depicts the spatial distribution of residential population expressed as an absolute numbers of inhabitants of the cell. The residence population estimates between 1975 and 2020 in 5 years interval, and the projection of 2025 and 2020 is derived from CIESIN, and 11 were disaggregated from census or administrative units to grid cell, informed by the distribution, volume and classification of build-up area as mapped in the global GHSL build-up surface layer. And now we're going to navigate to the band section here. So we have this particular band called population count, so which has a resolution of around 100 meters of resolution, and with the band name is population count. So now we're going to get back to Earth Engine, and this particular dataset has only a single band. So on the next step, to access this particular dataset we're going to mention the variable called population data equals to Earth Engine dot image collection JRC GHLS P2023A GHS pop. And the next step we're going to set a visualization parameter for this layer. So to do that we're going to define a variable called population count vis, that is visualization, and the minimum we're going to mention 0 and the maximum value we're going to mention 100. And color palettes here indicates a different set of colors. So this particular color which indicates the high population, and this specific color which going to indicates the low population. And last, to add this layer we're going to define map.add layer population data and population count vis. So this referring to the visualization parameter we have created earlier. And next step we're going to output as a global population. So now first step we're going to visualize the global population layer. I'm going to turn this layer on and I'm going to click this layer called global population. So now we're going to visualize the global population layer. So now here you can able to visualize here. So all the blue areas here, for example, we're going to navigate to Shanghai here. So all the blue areas which indicates the high population density. So you can able to see here. So Shanghai, which the color which indicated here, it is so the blue color which indicates the high population, followed by the low populations are indicated in white color. You can able to see the color distinction. So you can able to see the color variation between the colors here. So blue, which indicates high population, and white, which indicates the low population. And this is a global population layer for entire globe here. And next step, let me navigate to my study region. So we're going to turn on my study region. So before that, I'm going to add this layer. So next step, we're going to add our population data for our selected study area. So we're going to mention map.add layer population data referring to this particular data set, and we're going to apply two bands in order to add all bands of this particular data set starting from 1975 to 2030, and we're going to clip it based on our region of interest, that is our region boundary, our study area. So this is our study area. Let me turn this on. So this is my study area, you can able to see. And next step, we're going to set the default visualization parameter for this layer, and we're going to output as a population band stacked. So now let us visualize this particular layer. So we're going to navigate to the layer section, and I'm going to turn this on here. So now here you can able to visualize it more clearly. I'm going to navigate to the layer and click this option, and I'm going to select one band as a grayscale, and I can select the desired year of my choice. For example, you can select 1975 or 2030 is according to your choice. For example, I'm going to select 1975, and in the custom section, I'm going to select stretch 90%. So once you selected the stretch 90%, I'm going to click apply. So this is the population data for 1975 for this specific study region. So we can able to see here the white patches. So the white patches, which indicates the highest population density, and whereas the gray scale, which indicates the lowest population density. So white areas, which indicates highest population. Let me turn off this particular layer, and you can able to clearly distinguish here. So white areas, which indicates the highest population density, and you can use your inspector tool here. I'm going to use my inspector tool, and I'm going to click here in this particular study area, this particular urban area. So you can able to see the population here. So right from starting from 1975 to 2030. So the population in 1975 was around for this specific study region on this specific point. So it was around 323.63, and in the 2000 it was around or 1995 or 1990 to 2000, the population was higher, and comparably in 2025 the population is significantly reduced compared between 1990 to 2000. You can able to see the population has reduced for this study region is around 333.51, and the population is expected to decrease in 2030 around 318.84. So for this specific selected point, so likewise you can select your any point of your choice. Let me turn off this administrative region. For example, I'm going to click here. So you can able to see the population here. So in the next step, we're going to visualize this particular in detail using the time series chart, that is to create a detailed population time series chart. So to do that, we're going to navigate to this create a variable called population chart equals to. So population chart is equals to ui.chart.image.series, and the image collection I'm going to mention is population data, which refers to this particular data, that is our global human settlement layer population data set. And next the region I'm going to mention our study region, that is our selected region of our interest, and followed by we're going to apply the statistical function called sum in order to calculate the sum of the total population per image. So to do that, we're going to define EarthEngine.reducer.sum function, and the spatial resolution of this particular images is 100 meters, which is given here. Let me show you that the population. So the population of this the resolution of this particular data is around 100 meters. You can able to see. So here I've specified the scale as 100 meter, and followed you can add additional thing to your chart, your time series chart. For example, I'm going to mention dot set chart type is line chart type, And the dot set options, we're going to mention the title as population changes over time. And you can add additional options to, for example, you can add the title text style, and likewise the title in year and format in year. And similarly the v-axis, we're going to mention the title as estimated population and title text style as italic. And you can add different things to your chart here using this given set of options. Now let us navigate to the option here. In order to visualize this chart, we're going to mention print population chart. So now let us take a look at this particular chart here. So we're going to navigate to this option called run, and I'm going to click run. So it's going to, this is our time series chart, population change over time for our study region. For this specific study region, it's lying in Bangladesh. So you can able to see this particular axis which indicates the estimated population versus this axis which indicates the year. So in 1990, you can able to see the population around was, so it was around 4.2 million population in 1980. And comparably, the population was pretty higher in 2005, which was around 5.7 million population. And now in the 2020, the population has around 5.5 million, and in 2025 the population is around 5.3 million. So you can able to see the decrease in the population. So in 2030 it is expected to be decreased around 5 million population. So you can able to see the downward trend in this graph here. The population has been reduced right from this particular year, from 2005. The population has been reduced in this study region. Likewise, most of the countries, the population has been reduced. You can analyze this particular, use this particular code to analyze the population change for any study region of your choice. So most of my analysis indicates the population has been reduced. So you can check the different study regions population. So for this study region, the population has been decreased, and the expected population in 2030 is it is around 5 million. But in 2005 the population was around 5.7 million population. So now currently, which indicates the downward trend in the population. And now let us talk about the interpretation part of this analysis. So the graph indicates the estimated population trend from 1975 to 2030 using our global human settlement layer dataset. So the key observation is the population steadily increased around 3.8 million in 1975 to a peak of approximately 5.8 million in 2005. And this reflects a rapid urbanization and population boom over 3 decades. But from 2005 to 2030, after reaching the peak in 2005, the population growth has stagnated and showed a gradual decline by 2030, the population is projected to decline around 5 million. So this may suggest the urban saturation or declining the birth rates, or the migration patterns influencing the population decreases. So the possible interpretation is the peak and fall could indicate the need for an adaptive infrastructure, from expansion to revitalization and sustainability. The drop after 2005 may reflects out the migration or the declining the birth rates, or possibly due to the economic shift and housing affordability or environmental factors. So the governments may need to address this aging population and employment opportunities or livability concerns. So now let us take a look at the application part of this particular study. So the first application is urban growth and expansion monitoring. So it identifies and quantifies an urban sprawl by tracking the population increase in metropolitan and pre-urban areas over time, and supports an urban planning decision by mapping high density zones and evaluating the infrastructure needs. And followed by the second application, which includes the demographic trend analysis. So analyze the long-term population trends at regional, national or local scales. So understand the population peak, migration and demographic shift due to the natural disasters, socio-economic factors or policy interventions. So followed by the site selection and resource allocation. So assist the government and NGOs in locating their priority areas for resource distribution, such as healthcare, education, housing and utility, and optimize the location for setting up the new public service based on the population density trends. And the fourth application, which includes the sustainable development and CDG monitoring. So evaluate the population pressures on land, water, and energy resources to support the sustainable goals. And fifth application, which includes emergency response and humanitarian planning, so aids in disaster preparedness by identifying the high risk and high density areas for targeted emergency response and evaluation planning, and monitor the population dynamics in conflicts or disaster prone zones to estimate the displaced populations. And the integration with the remote sensing and land use, so combining the population data with the land use and NDVI, or the nighttime light, or to study the impact of human activities on ecosystem and support the environmental impact assessment and land degradation monitoring. And last, the research and academic studies, so useful for socio-economic and spatial demographic studies, provides the baseline data for publications, policy papers, and academic on urbanization and population dynamics. So let me get back to Earth Engine. So in this video, I have shown you the population dynamics monitoring using GHSL dataset in Google Earth Engine. So thanks for watching, and make sure that you subscribe to our channel and give us a like. And the code link will be given in the description section of this video. So thanks for watching.